Hi everyone, welcome to this video. Today we are going to dive deep into one of the core parts of Java programming, the collections framework. Whether you're managing simple list of items or complex data sets, understanding collections is essential. In this video, we'll break down what collections are, discuss the main interfaces like list, set, queue, and map, and also explore how these structures make data handling much easier. So let's get started. What is collections framework? Before we dive into the details, let's start by understanding what the Java collections framework is and why it is so useful. Imagine you're in a massive library where you have shelves full of books organized by genre, author, and even publication year. You can think of this framework as that library, a structured way to organize and manage data. The collection framework provides several data structures or containers that allow us to store and organize groups of objects. It includes classes and interfaces designed to help us add, remove, search, and iterate through data effortlessly. And these structures aren't just for storage, they also support algorithms for sorting, searching, and managing data efficiently. Think of it as a toolbox for data management. A quick recap on generics. One important concept to know before we proceed in collection is generics. If you remember from our last session, generics in Java let us specify a type while defining the collections, which improves safety by ensuring that only certain data types are allowed in collection. Here's a quick refresher on naming convention. In Java collections, the letter E is commonly used to refer the elements within the collections. For example, in a list of names, each name is E or element. In maps, K and V stands for key and value. These notations help us quickly understand what kind of data each collection will hold, making the code easier to read and less error prone. Why the collection framework is essential? Like I said before, the collection framework is an integral part of Java, offering tools that will allow you to write cleaner, more efficient code. Imagine that you will need to have an operation where you will have to look for searching, or if you wanted to sort some data. You don't have to start something from the scratch and create your new data structure where you will wanted to do sorting or searching or accessing data differently or like ordering the sort. So these are the operations that will be required when you are going to develop some complex projects. As part of any complex projects, these operations will be by default required in your development. So during those times, you don't have to create those data structures manually, which would take more time and effort. With collections, Java handles these details. So you can focus on building the features because they're already built. Whether you're working on a small tool or a large application, collections provide the foundation for managing the data in Java. And also they will help you to scale to manage large data sets effectively. That is the very reason why collection framework is essential in Java. Key interfaces of Java collection framework. Java's collection framework revolves around four main interfaces. One is list, second is set, third is queue, and fourth is map. It is important to note that list, set, and queue all extend collection interface. Map is a separate and does not extend the collection. It is something that needs to be noted down. This distinction is because map is designed to store data in key value pair, while the other three handles collection of individual elements. Let's go through each of these interfaces one by one. Just in case if what is interface itself is getting complicated, please refer other videos that is posted in the previous sessions where what is interface and what is abstract and all those key terms are elaborated and explained so that it is not confusing to you while watching this session. So with no further ado, let's go to the list interface. List is one of the most commonly used interfaces because it represents an ordered collection. Think of it as like a playlist of songs in your favorite music app. Each song has a specific order and you can have a duplicate songs if you like. Classes that implement list include ArrayList and linked list. ArrayList is a resizable array, so it is good when you need fast access to elements by index. Linked list allow for quick insertion and deletion since each element points to the next, but it is slower for accessing elements by index. We would have seen that the primary data type, which is array, which will not primary. We would have seen the reference data type array type, which has one con in it that it is fixed size. But array list is a resizable array. So whenever you need a functionality where you need to have a faster access, then your best use case should be like to use array list because it has indexing in it. And whenever you will have to have an operation where you will need to do insertion or deletion of elements, during that point you will have to use linked list. Lists are perfect when you need to keep elements in specific order, such as maintaining to-do list where tasks are organized by priority, or in any scenario where duplicates are acceptable, like shopping list. Set interface. If list was like a playlist, set is more like a guest list at a party. No duplicates are allowed. Set is ideal when you want to store unique items and don't care about the order of elements. Three main implementation of sets are hash set, linked hash set, tree set. If there is no concern of what order your data is going to be stored and you still want a faster way to do that, then your choice should be hash set. Also, it is not sorted because it is not having an order. Sorting is not possible in the hash set. Linked hash set. This one maintains order in which your item is inserted. Third, we have tree set. It keeps elements sorted in natural or custom order, which is useful for tasks where you need to be organized, like sorting scores or ranking names. Sets are used in situations where uniqueness matters. For example, a set could store a list of registered users where each user's name or ID is unique. It is an efficient way to prevent duplicates and avoid unnecessary data checks. Queue interface. A queue is like a line at a store where people join at the back and those at the front are served first. This is first in, first out or FIFO principle. Two main implementation of queues are linked list, which can be used both on a list and queue with elements accessed in, first out order. Whereas in priority queue, prioritizes elements based on their value and not by the order they were added. For example, in a customer support queue, high priority tickets could be served before low priority ones, regardless of when they enter the queue. Queues are often used in scenarios where ordering by arrival or priority is essential, such as task scheduling in operating system or managing printing jobs. Finally, we have map interface. Unlike list, set, and queue, map is not a sub-interface of collection. A map is like a dictionary or a contact list where each key is unique and maps to a specific value. It's designed for key value pairs, so it's ideal when you need to quickly look up a data by unique identifier. The main implementation of map include hash map, linked hash map, and tree map. Hash map unordered but provides faster access. Linked hash map maintains the insertion order. Tree map keeps keys sorted and useful when there is need for traversal in a specific order. Map is useful in any scenario where you will need one-to-one mapping, such as storing a dictionary of names to phone numbers or employee IDs to record. Some of the common methods across the collections framework is add and remove, which will allow you to insert or delete an item, and size to track the number of items in the collection, contains to support the functionality of searching. Like I said, your collection framework will also give you the tools for searching. Iterator provides a way to loop through collections seamlessly. These methods are consistent across different types of collections. So once you need to know how to use them, you can apply them to many structures in the Java collections framework. So to wrap up, and here's a quick recap, use a list when you need ordered elements that allows duplicate like a playlist. Use a set when you need uniqueness is your priority like a guest list. Use a queue when you need a process element in an order like a checkout line. Use map when you need a dictionary of key value pair like contact list. Java Collection Framework is designed to help you to organize, manage, and access data in efficient ways, making it one of the most powerful tools for any developer. Thanks for watching, and let's look at these interfaces and their implementing classes code demonstration. Thanks for watching.